Hi everyone, let me introduce you to the concept of displacement current. This idea is first introduced by James Clerk Maxwell in the 19th century. He who is best known for his own electromagnetic theory represented by the Maxwell's equation. He proposed the displacement current when discovering a logical inconsistencies in the Ampere's second law. Ampere's second law. It states that the line integral of magnetic field B along a closed loop is equal to the mu naught times total current enclosed by the loop. When a wire has current going through it, we can use the Ampere's second law to find the magnetic field using the equation and also imagining a closed loop around the wire. Now let's create a circuit with a capacitor. Then try to use the Ampere's second law in between the two capacitors plate. We can see there are no wires, therefore no current going through the enclosed loop. So in theory, when using the Ampere's second law, when the current is equal to 0, the magnetic field B is also equal to 0. But according to Maxwell and his experiment, this is not the case. Maxwell found out there are magnetic field in the area. He said maybe there is something that acts like a current going through the loop and creates the magnetic field. So to solve this problem, he introduced the concept of displacement current. He suggests to include an additional contribution, ID, the displacement current, to the real current, which can also be called the conductor current. Now, a new equation is obtained, and it is called the Ampere-Maxwell law, where the displacement current is equal to epsilon naught times d over dt of electric flux.
So we continue to Maxwell equation for displacement current. So we start with continuity current equation, which is divergence of J is equal to negative d over dt rho v, which is rate of reduction of current. So this J is equal to the curl of H. Within this form, the empirical security law, where rho v is equal to divergence of D, flux density. So we substitute it and we get this equation. So in arithmetic, we learn that divergence of curl of something, we can get 0, any number. So from here, we get left hand side is equal to 0. But we see that in this equation, the right hand side, we can't prove that the equation is 0 also. So we can say that the equation is not valid. So to make the equation valid, Maxwell added something in the equation to make the equation valid, which is d over dt divergence of d. So we can see the left hand side and the right hand side, we get 0. So the equation become valid. So from here, from the equation, we get these equations, and this is the final equation for displacement current. So in case of imperfect dielectrics, where sigma is 0, so the J is become 0. So the displacement current is depend on the time varying d over dt flux density d. So from this equation, you can see that in static current, where the current is static, the the current displacement becomes 0. There will no current flow in the capacitor. While in time varying current, the current displacement become d over dt d. So time varying current is AC current. In case of perfect dielectrics, the displacement current is equal to the rate of change of flux density. So in here, in static current or in this DC voltage, there will no current flow inside a capacitor of perfect dielectrics because the flux density is static all the time. While in time varying current, in case of AC voltage, the displacement current will depend on the rate of change of the flux density. So there will be a short circuit for a capacitor when we connected it with AC voltage.
In order to understand the idea of displacement current, we are going to do a thought experiment where we will look at current that flow through capacitor. The current will flow from positive terminal into the negative terminal, which is like the red arrow, and it essentially will put positive charge in the plate of this capacitor. And what happened to the negative side of the capacitor? Having the flow of electron, which is going to go like the blue arrow, and negative charge are going to flow. But in the capacitor, there is nothing inside the plate of the capacitor. This is an insulator. So how does current flow through the insulator? So this is what we call displacement current, which will act like a current where no charge will really flow. To understand that this type of current we can write as J equal to the rate of change of the electric flux vector. The J is current density, and uh, and it will equal to the rate of change of electric flux vector. So here we have some electric flux vector that are going to build up across the capacitor, and if the electric flux vector within this capacitor change, it will act exactly like current is flowing whether real physical charge is moving or not. And this is what we call the displacement current.
So our example is the easiest. What we can see is the capacitive screen that we also see in our daily life that we use from the phone. Or we can see we can go to the mall or restaurant. There are more few that use this method. The capacitive touchscreen used to two type of material that we can use indium thin oxide or the copper oxide, but we usually use the indium thin oxide ITO. So this function when the something that can flow the current touch the surface that will point the, the charge at there. So there were two type of the capacitive screen, projectile and surface. Projective screen using tight grid of special sensor chip that can manage multiple touch. So this, for example, we can see at the touch screen phone, tablet, laptop, or anything else. So the things is the surface capacitive screen using its CVC sensor in the corner. You can see it used at the mall, just like the restaurant, just like McD, and KFC also use it sometimes in the picture also, I think. And also we can see at the ATM bank and machine ATM and used to select the language, and we need to select the option that having there. So it's the trilogy of how the capacitive screen works. So first of all, capacitive screen having a two layer, indium thin oxide and overlaid with the glass substrate. So when the battery or electric source connect to it, it will create the electric field across the screen. Then uh, with our finger or stylus pen, because our hand have the charge, positive and negative charge, so it will detect when you touch the screen. So changing capacitance when you touch the screen, the conductive material is your finger or stylus pen act as a conductive plate, forming a capacitor with the conductive layer on the screen. This creates a tiny but measurable change in the capacitance at the touch point. So when the capacitance flow in the current in the circuit, so the voltage drop will be happen. So change in capacitance result in a localized so voltage drop at the touch point. The voltage drop is detected by the touchscreen controller, which continuously monitor the electrical signal on the screen. So it will plot the where you touch it. So position correlation, the touchscreen control analyze the location and characteristic of the voltage drop to determine the precise position of the touch. So by comparing the signal from multiple touch point, in case of you might want to hold it longer or what you can say pinch, zooming or zoom out, it will know the data. What we can say it will transfer the data how much the point at there, so the phone can make a decision. So signal processing, once the touch position is determined, the touchscreen controller sends this information to device software or operating system. The software then execute the corresponding action or command associated with the touch input. For example, if you touch a specific point on the screen, this device will launch an application, open a menu, or you want to make another relation that we can see open the flashlight or want to pause or start the video. Then the response from your device may provide visual or haptic feedback to confirm that the touch is being registered. This feedback helps to improve the user experience by providing confirmation that is recognize the touch input. So maybe they have the experiment. So when touch the screen, it will generate how much the voltage drop. So they can see what comment that happen at there. So the touch input is seamlessly integrated into the device user interface, allowing users to interact with application, navigate menu, input text, and perform various tasks using intuitive touch gesture. So what we can see here, when you touch a phone, it will interact what you want. So that's all from how the capacitive screen works. So, and this more example application is the ATM screen. Using a surface capacitive screen, they only have a side only, not all all display. And you can see in restaurant also that the child play with their food. And the factory, because the factory need to have a data as every component at there. And you can see also in the automotive factory that produce a car or anything else. So that's all.